What's going on, Adam? I hear you, my brother. I call that the ring around the rosy. Yes. I got to go grab some. Be right back. We're going to go into turning this into a generator. Alrighty, hello my fellow YouTubers. This is Roy back again. I think we're gonna have to show some cool stuff here. Especially the inductor. Got you guys back again? So we can run one stuff at a time. As soon as I fired up this guy right here, bam, killed the internet. Blew out the bulb. Gotta put a new bulb back in. I guess it gets a little punchy. Hola.
No, calling you the wino now. You feel like the great feet.
Up right there.
Are you filming?
Yeah. Okay. Pretty cool stuff. So I must say that I'm dropping the voltage down on the Variac. I got the Variac down to like, oh man, it's just here's the start. So we're over here. So we're probably at 12 volts or so, maybe 15 volts. Where once you get it caught up to the 60 cycles, it gets going. You can see I have a tough time once in a while getting it going once it stops. I guess once I get my controller, my AC inverter, frequency inverter, I get that back. I blew up the old one, so got to get a new one. So once I get that back, I'll run that in here and change the 60 cycles down a little bit. I think it'd be easier to get the start going. Cool thing is I want to take this and what I was thinking was cool stuff is take this apart. All right, so there's your magnet. And I can feel the magnet vibrating right here. So pretty cool stuff that it's vibrating in my hand. What I was thinking was if I get this spinning, if I put it on two little barons and get it spinning, I wanted to hook it up to this guy. So if I hook up the shaft of this over, where did that thing go? Can't find it when you're looking for it, but I'll just grab this other one. So if I hook this shaft up to this and have this spinning, which is wants to spin in my hand right here, right now, it's like vibrating. It would spin this, and this right here put out a pretty good amount of power out of it. Little three-phase guy, which pretty much is set up on the inside like this. But cool little project on bunch of the other stuff that I'm working on right now. So we'll go put this back in here. We need the rubber piece that fell out. There it is. Sneak that back on. I'll have to turn the voltage up a little bit. That's about 45 volts, 50 volts. Pretty neat how the magnet can catch up to the frequency. Now I'll turn the Variac down. And I got it real low. I just turned it down real low. Got it running. Cool stuff. So, I've been missing today a lot. I had the day off, so sorry, Adam, that you're a little overworked over there. I feel you, man. I feel you. I get it all the time. But I happen to have the day off today, rainy day out, so I played in the workshop all day. And I know, I consider myself lucky. And I got to play around a little bit with this guy. And I went in deep on just the transistor with the resistor and capacitance and top load. Now, that's a humongous top load. And how much it draws, and did all that today. It was pretty cool The unique thing I found was that over here on the magic table, okay, I have set up my receiver and I have ground right there. And I started messing with it without ground. And I'm like, okay, let me get this straight. So we're putting out a signal, not like this signal, which is still running, magnetic kind of inverse square law thing going. So it has its barriers. And so does this. But this here, we're vibrating things. And what are we vibrating? You got the air, which is what? It is gas. We breathe in gas. So we have gas right here. We're vibrating gas is what we're doing. Vibrating gas. So we're vibrating the gas. What's in gas? In the gas, our air. So we got water. We have oxygen. The cool stuff is that gas reacts to these vibrations that you put out. Now, how you collect them, where they go, do they seek ground right away? I was waiting for somebody to chime in. I left the other side out. Cool thing about nitrogen, I want you to see something, Adam. Let's look on the chart. Let's pull it in right here. Let's pull it in on the periodic table. Composition of air, okay? Composition of air on the periodic table. So the green is your nitrogen. Sure is. So up top here, the green is the nitrogen. Look how much nitrogen, okay? So we're looks like we're banging. We're vibrating nitrogen gas. And then you got 78% nitrogen. And then you got oxygen is 20% and change. Argon, 1%. And then carbon dioxide, very low. So we're vibrating that, okay? Let's just start off there because nobody ever talks about what the hell you're doing when you're sending out this signal, if you want to call it, or vibration. You're better off calling it vibrating because you're literally vibrating. Now look, this is still going. Still turning. Coil's warm, not really that hot. What's up, Brandon? So nitrogen is flammable in vacuum. Interesting. What's up, my big guy? So that's interesting. So nitrogen is flammable in a vacuum. That's good to know. Because it also would require some type of oxygen to be flammable in vacuum. Wouldn't you think? And vacuum wouldn't have oxygen. Flammable. So I got to look a little bit more into the nitrogen because it seems to be the catalyst for what's getting vibrated in our media. Like Tesla says, the media, and Maxwell as well, the media consists of air, water, and metals. There's your media. And that's the media we are talking about, which is in my workshop, in all your guys' workshop. And obviously it's easily ionized. So how do we direct that? You know, there's back in the day, and you still have it going today, they have these thing called Yagi antennas, and they're very directional. So he obviously got a hold of what we're talking about in concept on how to utilize that rattle in the cage, we'll call it, that nitrogen gas that is vibrating. So let's go ahead, for instance. I'm going to show you a couple of things I did today with and without ground. So I need a hand right here. I'm going to go ahead and turn on. All right, we're going to, last time I did this, I turned this on, your camera went out. I can't make any promises, but what we're going to do is, I got that still running. You can see the fans still going. Coils are, it vibrated and scared me. It didn't shock me or nothing. The coils are still good. So it's a good running speed. I got the variac very low. I'd say that's less than 10 volts, if 10 volts. And we're gonna go ahead and kick on the power supply. Good luck, guys. I don't know if you're gonna be staying there. We'll see how that goes. Now the power supply. All right, we just kicked on. All right, so fire in a hole. So there's your wars. I got electromagnetic going. I got electrostatic. Well, yeah, electrostatic going. And let's give it a test here. I got a little setup here. You can see it lighting up. I'm not doing so good on its own out in space. All right, it's reacting to this guy here. So let's go ahead. I'm going to turn that off. So obviously there's some, the Slayer sensitive. Now we're back up. I'm going to say, watch, fire in a hole. All kinds of stuff going on. Let's just make sure we got damn power in my hand, out in the room. Let's bring it on over here. Let's get over to the pickup area. Now, obviously, it's off right now in my hand. I got this pickup, and let's see what we can do. Get you in a good position. So right there is ground. We're not going to use it yet. We're going to figure out how to get this to light up the LED, okay? Because right now we're outside the field line for instance, look, if you see me go near this top load, watch the, over here is the current draw, and you can see the current draw goes up, as well as when you put a light, okay, see it go up, and that's a field line on that side of the bubble. Now on the other side of the field line, on this side of the bubble, call it a node, the low pressure point, your high pressure, low pressure. We're back over here, which is basically a similar like coil. That is similar coil here. I got a top load on it for no damn reason. I got the top piece hooked up. I got like a little primary at the bottom. And let me see here. So we could probably throw another turn around it. And what do we have? Nothing going on there. Let's bring one. I got these Germanian. Oh, this one's broken. No wonder it's not working. Broken. I hate when that happens. Let's get a fresh new one. So we're going to go on this end. And let's try, for instance, let's just get rid of the top load. And let's try, for instance, we're just using the center coil, okay? And we're going to touch both ends, and maybe I'll get my fingers off of it because that has a lot to do with it. And you can see we're just touching the two ends of the coil, and the LED is bright. Okay. I would like to get my hands off it. Yeah, so it's still on. So it's right there, still on bright. You can see it. So we just touched the two ends. Now, does this have anything to do with it? I don't think so right now, the way it's lit up. Pretty bright. So we're picking it up over here. And you got to ask yourself, all right, why? Why is it coming across from there, over there, to over here? And then what I start doing is dismantling everything. As soon as I see something start working, I want to know what's causing it. So I always go into the process of dismantling stuff. So like, for instance, can we get these wires to light up another light bulb? Well, let's get another bulb and let's see. We'll get this hooked up to this side, and then we'll try it over here. Nothing. Not a damn thing. But what if we introduce ground? So what if right now I just say, hey, Mr. Ground, and let's go down to that guy. I'm going to hook up a wire to him, and then we'll hook a wire up there, and we're going to see if bringing ground does anything. And why would ground do anything if it does anything? Hook ground up over here. I don't know what happened, but I just seen the light go on. So we got a light. Now, here's the ground. Can you see my fingers? Here's the ground. Let's disconnect the ground. All right, light went off. Why? Here's ground. So all of a sudden we have ground on in the circuit. And we're just feeding off the primary cables there. And for some reason, let's do this. Let's rewind this. So you can see the brightness right now. Okay. Watch the brightness when I hook up the one leg of the primary side to ground. Night and day difference. So that tells us right away that ground would be doing what? Is it pulling in, or is it coming up from the ground? So, and that's a good thing to ask right now, is like, where's the energy coming from? I'm right now floating in real air because there is no ground. We have 2N3055, got a 10 watt 1 ohm resistor, ceramic resistor, and we're just coming in here with 15 volts. I'm not even flying big volts, guys. I'm just using 15. I could step it up. This thing really runs good and smooth, about 24 volts. So here we are with almost a half an amp, 24 volts. So we just stepped it up a little bit, and we're doing good. Not that hot. Not hot at all. And we're switching this on and off. And over here, I always question myself. Then over here, you got this bright light, and you got, I think about this. Here I'm hooked to ground, Here I'm not. So what if we come over here and here's a ground wire. What if we come over here and we introduce earth ground? So we want to get the bottom end of this, which is the bottom end of the secondary comes out, and it's the switching device 4 to 2N3055. It goes to the base. But before it goes to the base, it goes to the one end of the resistor. So let's just say we want less stuff to go to the base because whatever's coming out of here is the other half is coming out of the bottom. So to protect ourselves, we want to, let's say we tap into this right here and go in the base. Let's just see if anything changes. You know why? The reason why. The reason why is because if we could use the Slayer to tap, to ping in the ground, we're already showing that the vibration of the elements is working. So how do we run from that? You know what I mean? I'm gonna have to put you down right here. I need two hands to do this. There we go. Sorry about that, guys. That stung me a little bit. Yeah. I think I fried. Yeah, I did. Switch out. Engine switch out. Yep. This is why through experimenting we go through these 2N3055s. But the cool thing is, what do you think is gonna happen when we add ground to this side? Are we gonna be pinging the ground? Is the ground gonna respond to this? That new engine. How do you like that pit stop? So here we are is our tap. Over here is our ground. Let's hunt down some type of. Oh, geez, where is an alligator clip when you need one? Right here. All right, so we're gonna go to ground, and we're gonna tap into this. Wow, wow, wow. Wait till you see what just happened. Put your eyeballs over on the amps, okay? Wait till you see this. So look how high our amps are, 1.5, 1.10. Now I'm going to go ahead and I'm going to connect this wire. Take a look at both there. Watch what happens to the amps. The amps drop down in half. So we killed half the amps. But let's take that back off. Let's put the ground back on. So we're drawing less out of the prime mover. But for some reason, we whacked it out. This light is not on. The light is not on, so we whacked it out. So let's go ahead and pull it off. The amps went back up. The lights back up. And the light's lit over here. So we know that that spot is not the spot we're going to tap into ground, okay? This is how I do my stuff. Process of elimination. So where do we go from here if we want to tap in the ground? Let's say if we're going to tap into the rail of ground. What would that do for us? Let's go ahead and find out. Wait a minute. It's on right now. It's at 87. Now it's off. So we're dropping down a little bit. Let's see what happens with our lights. Light on. Light is on. So now we have ground hooked up into the circuitry. Let me tell you what's important about this. Is that I've noticed several times. You see these little. Let me get you over there. There's little like screws, and you see them little screws right there, guys. See the metal, little screws? When I touch that, I get like a burn, the same burn I get from when I touch the top load when the transistor is running. So, so there's a lot of feedback going to the power supply. A lot of feedback going to the power supply. So, if we add the negative to the rail, let me check and see if I get burned. And if I don't get burned, that means that now is going to the path of least resistance and it's going out to ground. Now, the good part of that, it's pinging the ground now. It's not floating in air like we had it. Oh, I just got burnt. Yeah, you can. Let's see if I can show you. So I'm still getting you could call it back anything. Let me put a screwdriver there. Got burns. I don't see no spark. But I tell you what, feel it on my finger. That burns. Ooh, so does that. They get burn marks on my fingers. Anyway, so now we're pinging the ground. Now we have a rod in the ground over here. Now what's going on over here? Because all of a sudden now, we're actually sending a slayer, if you want to call it. We're pinging the ground. Got one light on, and that's running just off of the secondary. Let's get you guys up a little bit. All right, so what if we pay attention more to the ground? What if we bring in a air capacitor? What if we treat, you see power's coming in here, right? What if we go after one leg of that? And we're going to make one leg of this air capacitor to be a variable top load. You follow me? So we're going to sort of make this into a virtual capacitor, okay? Now let's go ahead and so one side we're fired up here. We also know that if we fire up the other side, that we're going to have some sort of energy going in there because the LED just showed us that. So there's some type of capacitance that should occur in this air capacitor. Some type of capacitance should be going on right in there now. So we have ground wear. Ground's coming up. So let's just say we introduce ground here. So we have two connections. All right, and we're going to go ahead and just connect ground to the bottom section. So you kind of have a splitter there with ground, and then you have the bottom part of that secondary there. Now you have the top wire needs to come in between. Let's put this LED in between them. If we get this LED to light up, we should be able to get it lit up by turning this capacitor. All right, so LED's on now. Now I'm using this as a top load. You guys like that? Ain't that pretty cool? So this LED now has this air capacitor as a capacitance that's going. Remember, watch, I'm going to disconnect the ground. You still see it on, but lightly, right? Connect ground. Look how bright. Look how much more energy happens all of a sudden. And we're going to look at something real quick because now we're on the outer field of this coil here. And I'm going to go ahead and get you tuned into that. Yep, into that. Right there is the amp draw of what this is doing. Let's see if the outer field affects the inner field, because this is where I think you can tap into energy that's not related to the, I would call it the inverse square law to this electromagnetic operation going on over there. So I connected to ground. The light got brighter. Let me go ahead and tune this. It's hard to turn this one. I had it preset. So now it's going down. Oh, right there. Right there is the capacitance at once. So look how bright. Oh, shit. All right, we're just going to call that good stuff there, right? I got it back here, but so we ran one leg into earth ground. We ran a LED in there. It's a pretty good setup. You guys just go back over the video. You can see what I did. I'm using capacitance with ground. Instead of just using a top load, I'm using the wires. We can see here that we're got a good distance. We're not pulling any energy from the inner field on the outer field. And this deserves a lot more research. And I can't wait I got ADD, so I got to be doing multiple tasks. So that's why you see me popping up different vids. Plus, I like to mix it up a little bit. Hope you guys have a great night. Hope you guys enjoy the whole mixing up stuff. The only thing I'm missing here is my Van de Graaff with some static. You know, this vibrates the media, and the static is like an event. So that Van de Graaff, when you push out that energy, it's a whole ball. So it becomes an event. This here is rattling everything around it, and you can see it has nodes about it. Has low pressures and high pressures. I'll talk to you guys later. Hopefully you enjoyed. Peace out, my brohams and bro ladies.